Good morning, everyone. Today we will talk about system designing in OS introductions. The system designing in OS involves the define how the components interacted to provide the service such as process management, memory management, and file systems. It ensures this efficiency, reliabilities, and scalabilities. Next slide. Goal of system designs: efficiency, scale, scalability, security, portability, efficiency, optimized resource utilization, scalability, support increasing the workload, security, prevent unauthorized access, portability, running a different hardware platform. Next, operation system architecture, monolithic kernel, all OS function in the large program. Example Linux, microkernel, minimal kernel moving server to user space. Linux, example Linux. Layer architecture, dividing OS into the layer for modularity. Types of OS: batch OS, time sharing OS, real time OS, distribution OS. The batch OS, the process of task in a batch with minimal user interactions. Time sharing OS, allowing multiple users to sharing the system resource. Real time OS, process the task which is strict time constrained. Distributing OS, manage a network for interconnected system. Next, system designing consideration, resource allocation strategies, performance optimization, tolerance and reliabilities, security policies. Next, process management handles the execution of process, include the scheduling, creation, and termination. Uses algorithm like first come first served, FCFS, short job next, SJS, round robin. Next, thread management, the thread allowing multiple operation to run in the parallel within a process, improving the system efficiency. Their types are user level thread, kernel thread. Next, memory management. The memory management is allotted using technique like pagings, segmentation, virtual memories. Next, file system designing. Define how the files are stored, accessed, or organized. Common system like FAT, NTFS, ext4. Next, input and output system designs. Handle the interactions with the hardware device using device driver buffer technique. Next, security and protection machines. Ensure the data integrity and privacy throws. Authentications, encryption, access control machines. Next, concurrency and synchronization. Manage multiple process running simultaneously, preventing race conditions, deadlocks. Next, virtual in OS designs. The virtualizations allows multiple OS instances to run on single physical machines using hypervisor like VMware Hyper-V. Next, OS implementation of PAS. Step in OS development, requirement analysis, system designs, coding and integration, testing or deployment. Next, programming language for OS development. Common language used C++, C or assembly, Rusting for security focused OS. Next, bootstrapping and system initialization. The OS boot process to include BIOS, UEFI, Fusion, bootloader, LILO, GRUB, the kernel loading. Next, device driver and kernel modules. Device driver allow the OS to communicate with the hardware. Their types to include character driver, block driver, network drivers. Next, inter-process communication. IPC. This method enable to process to exchanging the data using pipes, sharing memories, message queues. Scheduling algorithms. This process scheduling strategies to include first come first server, short job first, multi-level quiz schedulings. Next, method to handling deadlocks. Sorry, strategies. The method handling deadlocks are deadlock prevention, deadlock avoidance algorithms, deadlock detections, or recovery. Next, file system implementation. The components are include file allocations method, continuous linked index, directory structure, journaling mechanisms. Next, networking of OS designs. The network to support in the OS included protocol stack implementation, TCP in IP, packet programming, network security features. Next, fault tolerance and reliability. Strategies to improve the reliabilities, RAID storage configurations, checkpoint mechanisms, failover techniques. Next, performance optimization on OS. Performance technique included cachings, loading balancing, process scheduling. It's next, security challenges in OS implementation. Challenges are included malware protections, privilege privilege escalations, secure boot mechanisms. Case studies of Linux OS designs. Features of Linux: open source architecture, modular kernel, multi-user support. Next, GUI driven design is hybrid kernel architecture, security features, BitLocker, Defender. Next, version of different OS architecture: monolithic with microkernel, open resource with tree, performance trade off. Next, trend modern OS designs: cloud native OS, AI driven OS optimization, edges computing integration. Next, challenges in OS development: hardware compatibility, security threats, performance with security trades off. Conclusions and future scopes. The OS designs evolving with the AI ML based optimization, secure OS development technique, clouds and distribution of computing integration. Thank you for everyone.